Okay, here's where we are. Solving exponential equations. We are going to learn 3 methods for solving exponential equations. Remember this, an exponential equation is one where if you look at the exponent, it's got a variable in it. And there are 3 techniques for solving an exponential equation. 1 is like bases. We're about to work on that one. 2 is brute force, trial and error. 3 is take advantage of logarithms. And by the time you learn 1 and 2, you will really appreciate logarithms when we get to those. So we're doing the first 2 today, and we'll get to logarithms next time. You have this table on your notes. You have to understand what's going on here. Along this side, these are bases. And along the top up here, we have exponents. So this says 2 to the second power is 4. You know that. 2 to the third power is 8. 2 to the fourth power is 16. If you do 5 to the third power, it's 125. 5 to the fifth power is 3,125. You probably don't know this one off the top of your head. 7 to the sixth power is 117,649. That's how the charts work. So if you are wanting to solve, example, we want to solve this equation. That means find the value of x that makes the left side equal the right side. You got to look at this and recognize this is an exponential equation. How do I know? When I look at the exponent position, I see a variable. So in order to solve this one, we notice I've got 4 to a power equals 4 to a power. The only way this equation can be true is if these exponents have to mean the same thing. So this one's an easy one. We already had like bases. So we just have to solve. When is x plus 5 going to equal 3x minus 2? It's a linear equation. Solve. If you subtract 3x from both sides, then negative 2x plus 5 equals negative 2. And if you subtract 5 from both sides, then negative 2x equals negative 7. And if you divide both sides by negative 2, a negative divided by a negative turns into positive. We have just x equals positive 7 halves, or I can call it 3.5 because that decimal means exactly the same thing as 7 halves. An exact fraction is always better than a rounded decimal. If they mean the same thing, I mean, if they're both equal, then one's as good as the other. I want us to check it, so that's why I wrote it as 3.5. So here's how you're going to check it. Do 3.5, store it as x. 3.5, enter, store as x. Now type 4 raised to all of this exponent, all of the x plus 5, enter. Then do 4 raised to all of 3x minus 2, enter. These two things better be the same, are they? Yeah, it checks. So that's how you can be sure that you found the right value of x that will make the left side equal the right side. You solved. The plot thickens. Example 2. 27 and 81. Those are not like bases. Like bases, just needed to have an S on it. Those are not like bases. But if you look in your chart and you think about this for a minute, do 27 and 81 have a base in common? What is it? 9 and 3. Yeah. We haven't even gone down as far as 9, but 9 to the first is 9. 9 to the second is 81. There's no exponent that you can raise 9 to and get 27. Now 9 times 3 is 27, but you're looking for an exponent. So in your chart here, 27 and 81, if you look back over for a base that they both have in common, it's 3. So here's what we're going to do. We're going to rewrite 27, and we're going to refer to it as 3 to the third. But 27 is raised to another exponent. So when I replace it and call it 3 to the third, it still has to be raised to the 2x power because 27 was raised to the 2x power. And 81, I'm going to replace 81 and call it 3 to the 4th power. But 81 was raised to another exponent of 4x plus 1, so 3 to the 4th has to be raised to the 4x plus 1. You got to remember exponent rules. I have one base and a power, then another power. That's when we multiply. So if I multiply 3 times 2x, I have 3 to the 6x equals, I've got one base and a power and another power, multiply exponents. I've got to multiply 4 times all of this. That means distribute, help me. So that gives me 3 to the 16x plus 4. Don't forget to give the power, don't forget to distribute it. Now we're back to where we were before. Notice we have like bases. So the only way the left side can equal the right side is if the exponents are equal. So you have to write a little equation that says 6x must equal 16x plus 4 and solve that. So if you subtract 16x from both sides, then you have negative 10x equals 4. And then you divide both sides by negative 10. And x equals a positive divided by negative 2/5. I want you to check it. Is negative 2/5 really the correct value of x that makes the left equal the right? Do this. Do negative 2 divided by 5, enter, store as x. Then, you got to be careful. If you're going to check this, will it be okay if you just type 27 raised to the 2x power? You're going to run into trouble if you do this because your calculator follows the order of operations. Please excuse my dear Aunt Sally. It does exponents before it multiplies. So here's what your calculator will do with this. It'll do 27 raised to the 2nd power. It'll square it. It'll get an answer, and then it'll multiply all of that answer by negative 2/5. That is not what you want your calculator to do. You want your calculator to do 2 times negative 2/5 first, so you have to tell it to do that by putting parentheses in it. 27 raised to the 2x. Keep that number on your screen. Then type in 81 raised to the entire exponent of 4x plus 1. You have to put it in parentheses. Check it. Do these numbers mean the same thing? You got the same value. That tells you you found the correct value of x. Here's one more. 1/16 equals 64 to the 3x minus 2 power. Solve. What does that mean? That means find the variable, solve for x. What value of x will make the left side and the right side have the same value? Well, you look at this equation and you say, this is an exponential equation. How do I know? Because if I look at this exponent, I see a variable. Anytime you have a variable in the exponent spot, it's an exponential equation. We're going to learn 3 methods for solving exponential equations. The only one we've talked about so far is like bases. So if you look over there in the chart, do you see 1/16 and 64 and a base that they have in common? Be careful, you got to be with me here. There are no fractions over there in that chart, are there? So instead of 1/16, how about 16? Do you see a common base for just 16 and 64? 16 and 64 both share a base of 2. 16 and 64 both share a base of 4. You could get like base of 2 or like bases of 4. Either one would work. Well, since these two are next door neighbors, I'll go with 4 as my like base. Now you got to think. There's not a 1/16 in the table. 4 to the 2nd power is 16. What exponent would I need if I don't want 16, but instead I want 1/16? There you go. Instead of, to get 1/16, I'm going to raise 4 to the negative 2 power. Okay, let me remind you, because it's been a while, but early on, this is one of the first things we learned, what to do with a negative exponent. You don't, it's not negative 8.
Put it over 1.
4 to the negative 2 under would be 1 over 4 to the positive 2, which is 1/16. So if you have a fraction that you are needing to get, you're going to have to use a negative exponent to get the fraction. Are you okay? So we got 4 to the negative 2. Instead of 64, how do I get 64? With a base. But we're not using 8 as our base. We're using 4 and 16 have a common base of 4. So we're using 4 as our base. So 4 to what power gives you 64?
Third.
So we got 4 to the third. That still has to be raised to the 3x minus 2 power. On the right side, I have one base and a power and another power. So I have to multiply. 4 to the negative 2 equals 4 to the, I'm going to have to distribute to have 9x minus 6. And now I have like bases. And the only way these two things can mean the same is if the exponents are equal. So if I solve, I know that negative 2 has to equal 9x minus 6. If I add 6 on both sides, then negative 2 plus 6, 4 equals 9x. And if we divide both sides by 9, then we find x equals 4 9ths. I want you to check it. Do 4 divided by 9, enter, then store as x. Type 1 divided by 16. Leave that on your calculator. Then type 64 raised to all of this 3x minus 2. And when you type 3x minus 2, your calculator is doing 3 times 4 ninths minus 2. Did you get the same thing? 4 ninths is the right value of x to make the left side equal the right side. We solved an exponential equation. Look on your homework for just a minute. On your homework page, section 4 says solve using like bases. This is the one I gave y'all last time that it has 10 problems on the front side of it. I'll give you another one in a minute if you need it.
I think I might have it.
Okay. Look at letter D. On letter D, the problem is 1/6 raised to the x minus 3 equals 6 raised to the x minus 1. It's an exponential equation. How do we know? If we look at the exponent, it has a variable in it. We're going to learn 3 ways to solve. Is it still on?
Yeah, it's still going. It's just asking to sign into iCloud.
Okay.
But it's still recording.
It's still going. Okay. I'll turn it off in a minute. So on this one, what like base would you have for 1/6 and 6? How about just 6? Yeah, what if I'm going to write both of these using 6 as a base, what power do you have to raise 6 to in order to make it turn into 1/6? Yeah, 6 to the negative 1 will turn into 1/6. Are you okay? So then 6 to the negative 1, 1/6 was raised to the x minus 3. So 6 to the negative 1 is also raised to the x minus 3. And you should be able to finish it from here because it's just like the other ones. Look at one more. I'll give you one more hint. Look on F. On F, you have 1 over 32 raised to a power of x plus 2 equals 1/8 raised to a power of x minus 4. There are no fractions in that chart over there. So instead of looking at 1 over 32 and 1 over 8, just look at 32 and 8. Do you see a base that 32 and 8 both share? 2. Here's 8. How do you say 8 using a base of 2? 2 to the, well, 2 to the third will give you 8, and if you really need 1 over 8, you're right, you're gonna have to have 2 to the negative 3, then still x minus 4. 1 over 32, well, if you want 32, just 32, it's 2 to the 5th. If you want it to turn into 1 over 32, it has to be 2 to the negative 5th. Okay? So on the middle section of your homework, you are solving using like bases. These examples should help you do that. Bailey, will you stop it for a minute?